Hopefully everyone can hear me. Great. Thanks. Thank you guys for attending the Taraxa developer update for May of 2024. My name is Stephen Pu. I'm one of the co-founders of the Taraxa project. Hello, everyone. Hopefully everyone can hear me. Sorry about that. A little bit of feedback. All right. So as usual, we'll start out with a few logistical reminders. We hold these developer updates on the second Thursday of each month. So mark your calendars. It's going to happen on every second Thursday of each month. Most of the progress updates are included in our monthly update. So if you want and the monthly updates are typically published at the very beginning of the next month, for the end of the previous month. So a written record is already available prior to this. We will also publish a written transcript after each of these developer updates so that you have something to read if you happen to miss the update or just don't like listening to my voice. And if you have questions that you would like answered, the best way to make that happen is to submit them ahead of time or just ask them inside our social channels, Telegram, Discord, and just tag one of the admins, and we'll make sure to address it during the developer update. All right. So the first thing that everyone is, I guess, very excited about, and we're very excited about it as well, is really the bridge as well as the DeFi ecosystem, right? So we just published a near-term roadmap for the bridge as well as DeFi yesterday. And for the bridge itself, there's going to be a fully working operational version of the bridge on the testnet come a week of June 24th, and we'll be simultaneously starting a bug bounty on the testnet version so that we can invite people to come and try to break it. In the follow-up week, we're going to have a follow-up audit during the week of July 8th. I know this is very important because we had a first audit, which was very good, but we feel like there needs to be another audit after additional testing that we've done and deployments and redeployments. So we wanted to make triple sure that the bridge is secure. That's why we requested a follow-up audit. But the first date that they were available after the initial one was in July 8th. Okay, and that's why the mainnet mainnet deployment of the bridge is going to be on July 29th, because we need to have several weeks of time to deploy onto the mainnet, and obviously we can't deploy it before the audit is completed. So that's the bridge. It's going to be on the mainnet in the week of July 29th, testnet in the week of June 24th, which is coming up very quickly. And then also we're going to have a follow-up and final audit in the week of July 8th, prior to our mainnet deployment, of course. All right. So a bridge on its own is really kind of just a tool, right? A piece of infrastructure. And without an ecosystem of DeFi applications, bridge on its own doesn't really do much, right? So that's why we have been working very hard in the background to bring into the Taraxa ecosystem all the necessary puzzle pieces of a successful DeFi ecosystem, right? So we have DEXs coming out, Fusi app also has a launchpad. We have TerraSwap coming out later as well. We have liquid staking, the Lara protocol that's coming out. The only thing that's preventing Lara from really launching like today is because there is a minor change that we actually need to make in the DPoS contract, and that requires a hard fork on the mainnet. So we're going to do that after the bridge is completed, and so that's going to delay Lara a little bit. But rest assured, liquid staking is coming. It's definitely coming. It's a prioritized feature for the ecosystem, and we're going to do everything we can to make sure that it happens in a timely manner. We need oracles, and that's why we're working with Teller to actually introduce price oracles into the Taraxa ecosystem. Oracles are critical for any kind of lending protocols. Any kind of sophisticated DeFi protocols are going to require a real-time price oracle. So we're definitely bringing that into the ecosystem. And we need stablecoins, right? We've been talking to this project named Meridian, who actually has a synthetic stablecoin mechanism coupled with lending. It's forked off of this much larger and older project named Liquidity, which has been very, very stable, shall we say, on Ethereum for a very, very long time. We read into the financial collateralization model, the risk models, and we feel confident that this is obviously it's not without risk, but there are ways to mitigate the risk, and we feel that this is a great way to introduce stablecoin, and obviously with stablecoins, you're going to get a lot of liquidity inside the ecosystem, which is critical to any successful DeFi ecosystem. So and of course that's just the projects that we have been able to confirm that are going to come in. There's a lot more in the pipeline. A DeFi ecosystem has become a requirement for any layer one ecosystem to succeed, because obviously when developers want to make sure that when they are considering building in a layer one ecosystem, they're not only considering the technical side of things, they're also considering the liquidity side of things. So we are going to work very hard to make sure that there is significant liquidity inside the ecosystem, so that we become attractive to developers. Okay. So this is really, for us, it's an ecosystem launch for DeFi, right? Of which the bridge is one component. There are all these other components, and I think we have all the critical pieces in place. We're going to keep working to bringing more features and more applications. Okay. All right. So in terms of the DeFi ecosystem, right? So maybe we should go into a little bit more kind of detail into the DeFi ecosystem. So let's see. Um, anyway, I think we covered everything there. Yeah. All right. Quick updates from May. Some of the things that we some of the new partnerships that we've secured. So one is Tangem. Tangem has a hardware wallet. It's a cold storage, and they've supported Taraxa natively. So that's great. You guys can start using Tangem as your cold storage solution. Just remember, you can also use any hardware wallet that's compatible with MetaMask, that can actually connect to MetaMask. So things like anything that's listed on MetaMask's compatible hardware wallet list, you can use as well. So things like Ledger, Tracer, you can use all of them. But Tangem has a native integration, so that's very, very good. We've been working with them for a while, and it's really great to see that coming to fruition. Fusi Fox, they launched their AAA shooter game with ecosystem-specific NFT collectibles. So they're, I think, available in the Epic Store. So I think they're right now in early access. So go check it out. Looks like a really, really great game. The hackathon concluded, and we have some very interesting winners. I think one of the projects is extremely interesting. It's called Trixie, which actually leverages Taraxa's Echo network, which is a deepin for AI, to train a customized LLM that actually, it's a large language model that actually understands social text. So this enables a large range of very interesting use cases, automated, community management, automatic, real-time kind of do your own research. People always say do your own research. It's really hard to do your own research. I think the introduction of this model can actually give you extremely high quality do your own research information that's really, really up to date. You hear exactly what the community is saying about a specific project, rather than having to guess it and read through piles of text or listen to paid shows, right, on social media who are always going to say positive things about it. So, yeah, so there are a lot of interesting happening. All right, let's go into some of the questions. Yeah, let's go into some of the questions. We have some kind of interesting questions this time around. The first one, bridge. Does the bridge make Taraxa a layer 2, right? So this is actually a very interesting interpretation. So we have built a bridge that is based on light clients, on-chain light clients that actually do state root validations. And this does make Taraxa sort of like a layer 2, but let's sort of talk a little bit about what layer 2s are, right? So Layer twos are like batch processing layers. They instead of doing one thing at a time on a very expensive layer one, what layer twos do is that they take a lot of these transactions, most of them lower value transactions, higher frequency, lower value transactions, and they process them off the layer one chain, and they settle and do conflict resolutions on the layer one. So that's how layer twos work, right? And you can definitely use Taraxa that way. So if you say you're running a DApp, right, and in your DApp, you might have a lot of lower value, higher frequency transactions that might be extremely costly, for example, and you're free to deploy your DApp on Taraxa as well. Bridge over, and this is the key here, bridge over part of your assets or whatever information that you're kind of using, and then just do the do the higher frequency, lower value transactions on Taraxa, which is much faster and cheaper, and you can settle it back into Ethereum periodically if you like. So what the bridge is essentially doing is that it's making sure that the any DApp can actually have a single liquidity, right? Single liquidity, and not have to fragment their ecosystem by at the same time take advantage of a higher throughput, lower fee technical infrastructure. So in that sense, it is sort of like a layer two. I think people could definitely use it that way if they wanted to, right? Okay. So next question that people have is DeFi incentive program. So this is a great question. Obviously, DeFi is really nothing without incentives. So there are several things that we're very cognizant of. We're working with all the DeFi partners to make sure that there is sufficient incentive to attract liquidity and to attract activity in the DeFi ecosystem. Again, without incentives, it's really nothing, right? No one's going to use it. There are these aggregators like DeFi Llama and Dex Screener that actually rank a lot of the protocols, specific trading pools by the amount of incentives they actually give, right? So there's short-term high incentives. There are lots of different ways to play incentives. So we have partners that are in our ecosystem who run DEXs for a living, and they're very knowledgeable about how these incentive programs work. And we're going to go work with them to make sure that these incentive programs are successful. Because once again, without incentives, no one's going to use your DeFi anything, right? So we're we're very very aware of this, and we're working hard to make sure that we do hit that mark. I mean, that's part of the reason why we wanted to make sure that there is a synthetic stablecoin within the ecosystem, because that gives a lot of Terra holders within the ecosystem a lot of flexibility to actually synthetically create stablecoins into the ecosystem, significantly lowering kind of like the pressure that people might have to bridge over a ton of stablecoins, right, from Ethereum. All right. So account abstraction. Yes, we have account abstraction now because there's this project named Blockus, which has integrated with us a few months ago. Actually, interestingly, we're working with Blockus to actually partner up with game studios and game incubators. So hopefully we're able to actually bring in a lot of games, right, through them into the Taraxa ecosystem. Everyone loves games, and that's going to, I think, be a very big stimulus for the ecosystem. So Blockus already deployed account abstraction, and if you're interested in it, let us know. We can, get in touch with Blockus and see how they can work that out. And yeah, so account abstraction is on Taraxa. It works, especially if you're playing games. I think it has become really a de facto requirement for anybody who wants to create games in Web3, because gamers really don't have the patience of, obviously signing up for wallets, switching between wallets, pay gas fees, and all that kind of stuff. So they want everything in game, smooth, don't interrupt the gaming experience. Okay. Wow. Okay. So we have a bunch of technical questions. This is interesting. A while ago, we both myself and Justin we wrote some tweet threads around Terra and Say network, and the I guess this person wanted an explanation of those tweets. So they are pretty technical, and I'll try to kind of simplify a little bit. This is really, and you'll see this theme kind of recurring, right, throughout any technical ecosystems, right? And crypto is no exception. That people have different approaches to solving the same problem, and each approach has pros and cons, right? Has pros and cons. So the primary driver of Say networks speed up is their use of what's called optimistic concurrency. So optimistic concurrency is sort of like a way to explain it is sort of like you run things in parallel, right? Which seems like a no-brainer. Like why wouldn't you run things in parallel, right? So you run programs, run instructions in parallel, and hope that they don't conflict, right? Kind of pray that they don't conflict. That's the optimistic part. Um, so if they don't conflict, right? If there are no conflicts within the between the parallel executions, then great. You just like 4 or 5x or even 10x the speed, right? But the problem is that there are often a lot of conflict. So what is a conflict? A conflict is sort of like, if you're running one transaction and you're running another transaction, and the two transactions are trying to touch the same data. So it's sort of like I send one coin from my wallet to Alice, and I send another coin from my wallet to Bob. And if I only had one coin in my wallet, what happens, right? If you're executing everything sequentially, like one after the other, no parallel, then whichever comes first succeeds, right? If Alice comes first and I send one coin to Alice, succeeds. And the second transaction where I send one coin to Bob, that fails because now I have no coins to send, right? But if you do it in parallel, you could run into a situation in which both of them actually succeeds, and you end up with a -1 balance at the end, right? It's very, very, very tricky because at the beginning of these two parallel executions, they both see that you have one coin in your wallet. So technically speaking, both of them work. So that's a conflict, right? As soon as you touch the same data, the same state, you're supposed to just stop the related parallel transactions, and then roll them back and do them, and do them again in sequence, right? Because obviously you can't do those two in parallel. What's very interesting is that our advisor, Dr. Or Professor Herdeke, Morris Herdeke from Brown University, he's kind of like the grandfather of concurrency. Okay, so he came up with the most seminal theories on a lot of software as well as hardware concurrency theories. So we back all the way back in 2018, we actually did a lot of research along with him to figure out whether or not a concurrent VM was worth it. And the result being it wasn't worth it. The reason is because there are too many conflicts that are on Ethereum. So if you take Ethereum's past history and you replay it right into a concurrent VM, what you'll see is that there are tons of conflicts. And as time went on over the history of Ethereum, the more the longer the chain runs, the more conflicts you see. So as soon as there's a conflict, you using optimistic concurrency actually penalizes you. So not only do you not get a speed up, you're actually even slower than if you hadn't used optimistic concurrency, right? So there's a big penalty, and if there's such a large significant portion of the transactions that we saw that were on Ethereum that had conflicts if you try to run them in parallel. And so we thought, hey, this is not really worth it because you end up with a slower VM than the normal VM, right? Then you just did nothing and just used the off-the-shelf EVM model. So that's when we said, so look, this is not really worth pursuing. Now, the interesting thing is that like the only way to really make concurrency work is if everybody wrote concurrent code, right? So there are lots of programming paradigms and programming tools that are built into programming languages that actually help you write code that execute in parallel. to minimize these, to declare conflicts ahead of time, and to minimize conflicts as you're coding. So there are lots of these ways that you can actually optimize your code. The problem is that humans, are extremely bad at writing concurrent code. They're just really really bad at it. They were bad at it 10 years ago. They're still very bad at it today. And people trying to write concurrent code is going to create disasters, I think, on blockchains, because even without concurrent code, Solidity contracts are running into a lot of problems already. So the solution to that would be to actually create pre-compiled concurrent modules. So people are really bad at writing concurrent code. Let's just write it for them. Let's get a bunch of experts to write the code ahead of time for them, so they don't have to do it anymore, right? But obviously, the downside of these modules is that you have to have specific use cases for these modules. Like, what are you going to use it for? These are application logic. So that's again, that's very tricky. What are you going to bet on, right? And back in 2018, 2017, 2018, it wasn't really sure what you would bet on. Like, what application are people running on blockchain that's so big and ubiquitous that you can bet on it by creating specialized, pre-written, pre-compiled concurrent modules. There was no answer for that, right? So fast forward 5, 6 years later, um, Dexys has become really, DeFi has really become the dominant use case, I think, on dominant and mature use case on layer ones. So so we're seeing a lot of people actually create customized modules concurrent for Dexys, right? So I think Solana did that with their order book, online order book. And I'm not sure that one's concurrent. And I think Say did that with customized modules, concurrent modules for Dexys, right? Not sure if it was a Dex or an order book. I think that the distinction between the two has been very blurry ever since Uniswap introduced their version 3 pools. But the bottom line here is that there is now potentially a very good argument that you can create specialized concurrence modules for people to use, as long as in the form of Dexys, right? In the form of Dexys. Now, again, you have a trade-off because the vast majority of the world's code is not concurrent, right? The overwhelming majority of Web3 code is not concurrent. On-chain code is not concurrent. So it's great that you have concurrent code, but it's not so great because now you have to recreate the whole DeFi ecosystem on your own, right? Because if you try to fork off of a Uniswap module, well, guess what? That doesn't really work. It doesn't use your concurrent module. You want to fork over Aave, for lending. Sorry, that's not built using concurrent modules either. So you run into a lot of problems. Then what happens is that your ecosystem becomes very isolated, right? It's no longer compatible or composable with other DeFi primitives and other DeFi applications. So you end up having to build everything over again on your own, because who else is going to do it, right? And you're going to have to convince everyone else to to kind of get on these new things, right, that you just built, and kind of siphon off liquidity from other places. So it's a very, very, very big task, and it's going to take a very, very long time. And it's unclear how long that would take to migrate. And in the meantime, you're kind of in this kind of awkward situation in which you're running your own super fast concurrent, VM with the super fast concurrent modules with Dexys, but no one else can work with you, right? And that's not a really great place to be. I guess if you have tons of money, you can just kind of do it yourself for a while, right? We know all these TVLs that we see out there are very much inorganically inflated. So we're not really sure that's what any specific projects are doing. So we saw all this back in 2018, right? Concurrent modules, incompatibility, blah 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 blah. So we said, look, this is not really doesn't look like it's worth it. And what we did is we said, let's just try to make EVM generally as fast as possible without really thinking about concurrency. And so that's what we ended up doing. We ended up natively integrating the EVM into a extremely high throughput network, which is a block DAC network. And this means that all applications, off the shelf application, right? Take any Ethereum application running on Taraxa, it just runs way faster, right? Way, way faster at much lower cost. So it's sort of an immediate gratification that it just works. It's compatible with everything, and it runs much faster and much cheaper. Right. So that's the benefit we're going for. I think the benefits of something like a say or specialized concurrent modules is you eventually see that, but maybe it's going to be years and years down the road. That's my opinion. Again, this is not really saying which one's better or which one's worse. There are trade-offs to all these different types of approaches. We actually built a concurrent VM back in 2018, right? So at Taraxa, we did a lot of research and we built a lot of stuff and tested them to make sure that they're actually viable, for the real world. If they weren't viable for the real world, we said it's not ready. We kind of hold it up. There are definitely kind of penalties to releasing these types of stuff early, right? I think Algorand, it's a great project. Obviously, tons of amazing research came out of that project. They have some of the cleanest and kind of best written code that we know of the entire industry. But I think they were kind of too early, right? So they released their layer one with a lot of these built-in pre-compiled financial primitives, like things like auctions and I think swapping and all these kind of things. But it feels like they did it too early. I think they released all this stuff back in 2019, I think. It didn't really catch on because again, they were too early, right? So it's difficult to time technologies and make sure that they're in perfect timing, with market forces. So we just, we're a small project again. We're a small project. We're not like huge like some of these other ones with unlimited funding. We're a smaller project, so we have to make sure that whatever benefit we bring to the market, differentiated benefit, is immediately felt. Right? It's we can't afford to kind of sit around and wait years and years, decades potentially for the rest of the industry to catch up. So that's why we did what we did, and that's why other projects, right, like Say did what they did. There are trade-offs, right? So um, in the future, I mean, I think I've talked about this several times. Eventually, we're going to introduce what are called sharded subgraphs into the network, so that each subgraph can be its own independent layer one, but it's also closely connected with all the other subgraphs, so that you can actually communicate with them. This is basically directly enabled by our by our bridge. So it's a really great architecture, and the let's see. And on one of these subgraphs, you could actually have concurrent modules, right? We could actually deploy a concurrent EVM with some concurrent modules. I mean, and people can try it out, right? Like if you want to stay in your own little concurrent world, you could try that. You could try that and see how much traction you get. And the more traction you get, the more inter graph communication you're going to have. So I think having them sit side by side is going to be kind of an interesting way to allow innovations like concurrent VMs to really, have a place and start working before they really become kind of like the industry standard. Yeah, so that's kind of a long-winded way to explain what we wrote. I encourage everyone to go back to the threads. You can just go to like my account at Revoid on Twitter, and it's one of the I think highlighted threads. You can actually read through that. It basically talks about the same thing in less words. So hopefully this makes sense. Bottom line here is, there are trade-offs with every single types of technical decision. We investigated into parallel execution VMs. We actually even built one back in 2018. We thought it wasn't worth it for all the reasons I said. And we still don't necessarily think it's worth it, but someone needs to start to do this at some point. So Say decided that it is worth it, and they're going to do it, right? So good on them, and obviously love to see how far they can take, how quickly they can drive concurrency within on-chain logic, right? Okay, so there's another question that actually asked about subgraphs, which is very interesting. So it's asking about subgraphs and our design decisions or design trade-offs versus AVAX subnets versus I think like this inter-chain protocol from is it from I mean there are two I keep getting the all these different names mixed up. There's Polkadot and then there's this other project. Sorry, I can't remember what it is. They both have these interchain protocol type of things, right? So okay, so I think I don't know those other protocols extremely well. Like I can't sit here and be like I'm an expert on AVAX and subnet or or whatever. But the idea of subgraphs is that they're independent networks, right? So that can communicate with each other. So and the reason why you might want to create that is if you stay in crypto for a while, what you notice is that there's a tendency for DApps to create their own layer ones. And this was foreseen, right? I think by the people that made the other one's called Cosmos. Yeah, by the people who made Polkadot and Cosmos, they foreseen kind of this thing that would happen. So they created these software architectures that let people just kind of build their own layer ones. Um, there's good and bad to that. I think the good part of that is people can. The good part is that they can build their own layer ones. The bad part about it is that they're constrained actually to this kind of not very fast network, right? I don't think Cosmos and Polkadot are very fast. I think they're actually very, very slow. And you can't really kind of jump out of that. So you end up building kind of a very slow network, which isn't ideal. Not too sure about AVAX or what they're doing because honestly haven't spent too much time studying them. But what we're doing with, or we plan to do, is subgraph. And again, don't quote me on any of this stuff about subgraphs because I think the dev team hasn't really started doing research into it. Right now, everyone on the entire team is working hard on the bridge. And so we don't really have time to look into the other things. So the subgraph idea is really kind of a preliminary idea that we haven't done a lot of research into. But in my mind, the subgraphs are going to be independent networks that are going to be connected through these the bridge that we built. Right, they're all going to be connected through the bridge we're going to build, and there's going to be cross anchoring of state roots across these different subgraphs, so that one and the other can kind of validate right intergraph communication. So that's what we're thinking of. The other interesting feature that we wanted to build into the subgraph is the ability for any DApp or any subgraph to actually create their own assets as a DPoS guarantee to protect themselves against Sybil attacks, right? So let's say you create a dog coin, and Dogcoin took off. It's great. So they're saying, well, Dogcoin needs its own subgraph because we don't really want to share this traffic throughput with other people anymore. Like the Dogcoin ecosystem is big enough that we're going to eat up like the entire throughput or the system resources of a subgraph. So, all right, great. So you create a subgraph. You get your community members and yourself run up some validator nodes for that subgraph. You can actually stake Dogcoin in that subgraph and use that to really help protect or augment the security of the network. We think that it's also going to be necessary for Terra to be involved in the security as well because it's difficult to understand the economic kind of security model if you have tons of different coins floating around acting as civil attack prevention stake. And so we think that having Terra restaked into other subgraphs is going to also add an extra layer of protection. In return, those who have staked their Terra into other subgraphs probably can get rewarded in Dogecoin or something, whatever. So I think that's an interesting financial economic security model that can actually go into these subgraphs as well. I mean, just an aside, the concept of restaking again isn't new, right? There's no new things. The things you see today, you think are new. People were talking about that all the way back in 2017 and 2018. So these are not new technical concepts, and it's a good idea, right? It's a good idea to really leverage security of a mature network, assets of a mature network into a relatively new network. Right? So sorry, I guess I didn't really answer your question or answer only half of it, but hopefully I outlined what we have envisioned for Taraxa subgraphs. And obviously, it's all subject to change because the development team hasn't done like an in-depth sort of research into it yet. So we got to wrap up our bridge before we get into that. And all right. So another kind of interesting technical question: how does Taraxa scale its validator set? So again, very very good question. So Taraxa's consensus is composed of like two big components, right? One is the block DAG, the other one is the asynchronous PBFT process. So the block DAG is in charge of packing transactions into blocks, right? So it's in charge of block inclusion. And the PBFT process is in charge of finalization, right? So those are the two things. On the block DAG side, there isn't really kind of like any kind of scaling going on because it's uncoordinated, right? So things that are uncoordinated typically kind of scale really well because they don't need to, the scale doesn't matter. Like as soon as, if you're a node and you're in kind of an uncoordinated consensus, you don't care if there's one other node out there or, it doesn't matter if the network's 2 nodes big or 20,000 nodes big. Like you don't care, right? You just do your own thing, compute your own VRF, VDF, and, whatever whatever transactions come your way, you pack them into a block, you send it off. That's it. You don't really care too much about how many other validators are out there. The only thing you care about is what you're doing and whether or not other validators are lying to you, for example. And then you blacklist liars and stuff like that. But so there's really not a lot of scaling problem there because the consensus doesn't require coordination, right? The PBFT side does require coordination because it's actively voting, right? So the way that works is that the committees in the PBFT is randomly selected out of the entire validator set. So these are randomized subcommittees that actually scales to log n, right? So basically, if your network increases by 10 times, the latency only increases by 2. Hopefully, I'm saying that right. Yeah. If it increases by 100 times, the latency only increases by 3, for example. So it scales really well because it's taking a randomized subset of the network. So just to repeat, the block DAC side of it is uncoordinated, so it scales just fine regardless how big the network is. And the voting side of it scales just fine because it uses a randomized subcommittee, which scales at the log of the size of the entire network, right? Or a network diameter. So that's on the voting side of things. This person also asked about gossiping. Gossiping is very interesting. So so I remember way back when, I think this project is still around. There's this project called like NTN, not new type of network. I think that's what it's called. So NTN is really interesting because they pointed out that there's a very big gossip problem within decentralized networks. In that there's a lot of redundant traffic, right? So the idea about the gossiping problem is each node will actually hear about the same information over and over and over again, right? They would hear about the same transactions, the same whatever, like many times, like 10. This is a long time ago when I read through their papers and saw their presentation. So it's like a 10 or 100 times or something very very big. So then they said, look, this is, this is a big problem, right? Because if people are kind of wasting their bandwidth, in hearing all this redundant gossip, and that means, the network is being extremely inefficient. At some point, a network's throughput is going to hit, physical bottlenecks, and the physical throughput, the throughput of the network itself, is going to be such a bottleneck. So if you're wasting a lot of the throughput on redundant gossip, then they're being very inefficient. Okay, so what's their solution, right? So their solution was to this is very interesting. So their solution is to not to gossip what you've heard to everyone else you know about. Their solution is to only gossip it to specific people, and those people are only going to gossip it to other specific people. I think their algorithm, and they fine tune it, right. It's probably like I don't remember the specifics, but I think it's some kind of a hashing distribution thing where, you kind of, you know, you kind of talk, you gossip what you know to every other person, and that person gossip to every other person. And so it kind of has this geometric decay in how far this thing gets gossiped, and eventually it gets to everybody. And they can adjust these overlap ratios. So instead of being something horrible like 10x, you hear the same thing 10 times. You only hear the same thing like 1.5 times or 2 times or something like that. So that's great. It sounds like a great algorithm, but the big trade-off there is that the network becomes highly coordinated, right? So at any given time, each node is no longer kind of, I don't care how many other peers are there in the network. They actually have to know who the other peers are. They need to know they also need to know their IP addresses, right? Because this traffic is actually routed, right, specifically to these people. So by doing that, they're actually increasing the latency of the network, and they're increasing the centralization of the network, because there's also like a routing mechanism in the network that's very centralized, because it needs to be aware of what everyone else is doing at any given time. I didn't look into the specific network performance of their protocol, but I think what I learned there, and this is a very early learning, right? This is back in again 2020, early 2018, is that obviously, if you try to reduce the gossip, there's a huge centralization and latency penalty to it, right? You do end up getting higher throughput, but you're trading something else off, right? So this goes back again to some of the things that we keep talking about is we wanted to figure out a way to scale throughput without sacrificing any of these critical security or decentralization guarantees. And this is what makes BlockDAX so amazing, right? It's able to massively scale throughput without sacrificing these things. There are a lot of things you can do, right? There are a lot of mechanisms you can do, right? Like like the one that NTN did, which is actually specifically solve a gossip problem, but you're sacrificing something else. Like you don't get stuff for free, right? Unless you fundamentally change the architecture. So the 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 um the pros, right? The upside of having really a lot of redundant gossip, repeated gossip, is that it actually makes your network less prone to not single point of failure, but like kind of small number of points of failure, right? Because if you have a highly coordinated kind of gossip architecture where you're only gossiping to specific people, every other people, and it's highly coordinated, if one or more of your gossip targets fail, right, in the middle of operation, then your network propagation like speed goes way down, because like now like some a critical linchpin inside your finely crafted gossip network just failed, and suddenly a lot of the network doesn't hear about a specific set of transactions, or don't hear about them for much later. So again, always a trade-off, right? And what we believe in is that we believe that decentralized networks are really meant to be very chaotic, and very kind of disorganized. You cannot make assumptions about the network connection quality. You cannot make assumptions about whether or not they're willing to abide by your high hardware or standards. And so this kind of finely tuned orchestration, centralized orchestration, but not only is it centralized, but it's kind of difficult to expect people to really have the right networking and hardware environments to make this work, right? What if they're in a very unreliable connection, then you're kind of screwed, right? In Taraxa, that doesn't happen. All the nodes could be on really unreliable connections. The network would run just fine because there's built-in redundancy, right? So again, lots of trade-offs. So hopefully this answers your question. It's a very technical question, both on voting and gossiping on network scaling. Okay. Okay, so this is another kind of technical questions about the bridge and what kind of trade-offs are we making versus the other types of bridges. So I think I alluded to this in a lot of the posts that we've been making, right? So Taraxa's bridge is slower and more expensive, but it's permissionless and transparent and secure, right? So those are the trade-offs. The mainstream bridges that we see today, things like Layer Zero and Wormhole, they use what's called an actively validated model. They're fast and cheaper, but they're permissioned, right? So try to get on Layer Zero with a new asset, new Layer One, whatever. Good luck, right? Good luck getting on there because you need the permission of their dev team, you need the permission of their network, you need permission for all kinds of stuff. So that's not cool, right? I mean, that's not really what decentralization is all about. But if you want everything to be perfectly permissionless, that means all the validation needs to be done on chain. Now, these on-chain validations require you to validate state roots and state proofs to make sure that if you say you did something on one side, you can actually prove it using state roots. So all these proofs are expensive operations, right? They're very cheap on Taraxa. They're like worthless to do on Taraxa, just like everything else. It's like super cheap and costs almost nothing to do on Taraxa. But remember, we're bridging between Ethereum and Taraxa, right? It is very expensive to do on Ethereum. It's very, very expensive, and especially later on when somebody drops like a hot airdrop or whatever on Ethereum, then the gas price goes way up, and it's going to be even more expensive. So, so the economics actually works out a little bit not too good, right? For validators because sorry, for the relayers that are actually doing all the validation. They're calling these on-chain smart contracts and paying the gas fees to do this validation. Again, when they call all these light clients and bridge contracts on the Taraxa side, it's trivial because it costs like nothing. When they call the Ethereum side, it costs a lot of money. We don't really see a lot of people right now, unfortunately, willing to run relayers because it costs so much money to run these stable validations on the Ethereum side. We're not really sure what is going to happen in the future. I think maybe as the amount of inter-chain traffic goes up, we can actually, there will be other people wanting to run the relayers maybe. But right now, the foundation is running these relayers and paying a lot of money to run the relayers, and all of it is going to gas fees, right, into the on the Ethereum side, and so and we don't want to use any layer twos because all these layer twos are centralized sequencers. It's kind of ridiculous. That's where we are right now with layer two scaling. They're so centralized. Anyway, that's what it is. And the reason why it's expensive is because Ethereum is expensive. It's slow because it's too expensive, right? We can't run it very frequently. And if you run it very frequently, it's going to cost millions of dollars each year to run one relayer. So we don't want to do that, right? We want to cut that number down to like tens of thousands of dollars or something like that. So that's the idea, right? And there's another, I think, very interesting property. So because the bridge is not actively validated, right? Oh, well, let me explain what actively validated means. Actively validated, like networks, like bridge networks like Layer Zero and Wormhole and all these other bridges, they don't they don't have these light clients on chain doing the validation, right? They're actually just validating off chain their own little network. And as long as the network says your transaction is correct, they'll just bridge it over for you, right? So they don't have a lot of on-chain cost, but again, as I explained before, it's highly kind of centralized and permission because there's just like a little private network that they're running, and you need to get permission from them to really add anything. So that's the trade-off. So there you go, right? You don't get anything for free. Oh, the other advantage I want to say is that for actively validated bridges, they need a lot of validators in their network to make it decentralized, right? To make it work, just like a proof of stake layer one kind of thing. But for the way that we're doing it, like this on-chain light client validation, you don't actually need a lot of nodes, right? So these relayers can't cheat because everything is actually deterministically validated on chain. If the relayers try to lie, it just gets rejected by the on-chain contract, right? So it doesn't really matter if one relayer or 100 relayers. I don't think it will ever get to that size because the financial incentive still isn't there. But the only reason to add more relayers is to create redundancy, right? Like, what if one relayer dies, right? And another relayer is still there and stuff like that. The total cost of the bridge is constant as long as the frequency of root state root anchoring is constant. But the adding more relayers would just make sure like one relayer dies, another relayer can kind of, there's still other relayers kind of relaying, right? So the bridge doesn't stop. But you don't need a large network because relayers cannot cheat. All the all the correctness security is guaranteed by these on-chain contracts, which everyone can see, open source. You can see it yourself. You can deploy it yourself too. And you can deploy a new bridge if you want to, right? It's just that the the economics right now for relayers are not great. I don't see why anyone would want to run another relayer. But then again, we don't need to incentivize a lot of people to run relayers because as long as you have like 2 or 3 relayers, you're fine. Like there's it having less relayers doesn't mean it's centralized because the correctness doesn't depend on the number of relayers. The relayers don't really have a lot of autonomy. It's not like they get to decide what goes through and what doesn't go through. It's the smart contracts on chain that gets to decide that. So the relayers can't really cheat, and there's no point in having a lot of them. So it's that's another advantage because obviously we can't be spending a lot of time building yet another network, right? That's just gonna suck up a lot of time and resources. So that hopefully gives you a good understanding of the types of trade-offs. Taraxa's ficus root bridge is secure, 100% permissionless, but it's slow and expensive. Versus someone else's bridge like Layer Zero, which is I guess cheaper and faster, except it's permissioned, right? You can't get everything in the world that you want. You have to make some sacrifices here. We just happen to dislike the fact that in Web3 you have all these permission and centralized things, right? So it's not great, not ideal. So let's provide an alternative here to what is in the market, and so that's it. We don't really expect there to be a ton of cross bridge activity. Because the only reason why I can think of that is people running massive arbitrage trades across ecosystems. That's probably what people are using these high frequency bridging activities for. And I mean, we're not gonna get that at least not in the beginning. And later on, if we do have a lot of demand for these type of higher frequency bridging activities, we can always offer another alternative and try to go back to someone like a layer zero and say, are you willing to integrate with us now, right? Because before they didn't care about us, but with sufficient activity, they might put us earlier in the queue, right? So that's another alternative that we can see. People who really want higher frequency stuff, they don't care about centralization. Sure, go use like someone like layer zero. But people who care about permissionlessness and decentralization, then they can keep using our own bridge. Um, so yeah, so that's the trade-off. Well, another trade-off is that if you're using someone else's bridge like layer zero, they can kick you off at any point, right? They're like, I don't like you anymore. We're gonna kick you off our bridge. We're gonna kick your asset off our bridge. We're gonna kick your layer one off our bridge because we don't like you anymore, right? So that's another reason why it's better to have an alternative where we have our own kind of bridge mechanism set up so no one can kick us off, right? Or no one can kick anyone off, really. You guys can deploy stuff and no one can kick you off, right? So those are the trade-offs. I don't really see a lot of high frequency use cases. What I really see is that people kind of bridging over a bunch of stable coins, a bunch of mainstream assets like Ethereum, from the Ethereum eco chain into Taraxa, and do whatever they want, trading, lending, restaking, whatever it is that they want to do. There's not going to be a high frequency use case, I don't think. And it also allows people who are building DApps that have their own tokens, to make sure that their token supply isn't sharded, right? So they can actually have the same token supply that's consistent across different ecosystems, and that's again not a high frequency activity, right? So when you come to the ecosystem, we want you to stay in the ecosystem, right? There's really not a lot of incentive to kind of get people to go the other way either. So anyway, those are the trade-offs. We think they fit the bridge that we built. The Ficus Root Bridge is going to fit our use cases and needs quite nicely. The one edge case of high frequency arbitrage trading, I don't think that applies to us, at least not in the near to midterm, right? So yeah, so that's our bridge. Okay, so we're really kind of going towards the end of the this dev update. Everyone keeps asking about marketing, right? So what's going on with marketing? What's the plan with marketing? So there's a lot to say here, but we're at the end. So let me just kind of quickly summarize what we're doing to really get the word out, right? So the current narrative that we're going to focus on is AI on Blockstack. Okay, and our BD efforts are going to really try to focus on getting a lot more partnerships around the Echo network, around AI agents, and really enriching our decentralized AI ecosystem. And then we're also going to try to secure large partnerships. We actually had some very promising conversations. So I'm feeling very optimistic about the prospects of forging really solid partnerships with extremely large AI ecosystems, right? So the things that we're doing and working on and researching on the Echo side of things are things that everyone is very interested in. So we're very excited about that. The reason why, and of course on the marketing side of things, is really to secure the partnership of extremely large influencers. Smaller influencers are fine. They don't move the needle. I think they provide like kind of a baseline of awareness, but they don't really move the needle. You gotta secure like one or two extremely large partnerships with large influencers who have tons of followers and who are very picky about which projects they work with, right? We don't want, obviously, there are a lot of influencers out there. You just pay them and they just work with anybody. That's not good, right? That's not going to be a good look for us and doesn't really build credibility. So we want to work with people that actually are very selective about which projects they work with, right? So why is this sort of emphasis on narratives, right? The entire crypto market obviously moves on narratives. unfortunately, right? I think that's probably the case for any financial market, in the stock market too. And most people really don't understand the products or services or the market dynamics of any of the companies that they actually put money into. Similar in crypto, people kind of do what everyone else is doing, right? So the dominant narratives that are in the market today are things like AI, real world assets, RWAs, deepen, restaking, right? Some of these things are really, really hot. We have been, I would say we've been lucky that we actually started building Echo like years and years ago, starting 2020, 2021, way before the AI boom, right? Way before AI was super hot. So we've been working on this for a long time. This is not a case of like some coin coming out, adding GPT to their name, and suddenly they're AI, right? So we've been working on these this AI platform and AI applications for many years, you know, and it's really again lucky, right? That we're riding in on this dominant market narrative. So so that's going to be our play, right? AI on BlockDAG, and we're going to be beating a lot more AI partnerships, AI applications and agents into the ecosystem, and we're going to be trying hard to secure large partnerships with KOLs. So that's really the way that we're going to do it. The DeFi is interesting, but it's not going to be like a dominant narrative for us. We're not going to be like a big DeFi player. We're going to be a good enough of a DeFi player so that we attract enough traffic, enough liquidity to make it attractive for other builders and other developers to build on top of, Taraxa's ecosystem. Um, being a pure play layer one, layer one is not a dominant narrative either right now, right? So again, you have to be very cognizant about what everyone's looking for. So AI on BlockDAG, that's what we're going to be going for. That's where all of our attention is going to be focused after the bridge, after the DeFi ecosystems. We're going to be very focused on all this stuff, and to make sure that we are recognized for all the great work, all the great engineering that we've been building, and get as many people to use it as possible, right? Because I think it's very useful. So all right. So hopefully that answers all the questions. I know there's probably a few questions that people are asking right now. Let me see. We're kind of going way over time here. Um, yeah, I think we're good. So yeah, we had some very good meetings recently. I'm not going to tell you anymore because they're not kind of like in iron yet, like but I think we're very confident about our ability to attract a lot of high profile, large scale partnerships within the AI ecosystem. Because again, we have great tech, we have great products. We're trying to solve the same problems that everyone else is trying to solve. So I think it's all very yeah, it's all looking up right from here on forward. So yeah. All right. So thank you guys very much for showing up. Obviously, per usual, if you have any other questions, feel free to ask them in Telegram. Feel free to ask them in Discord. We'll try to get the answers to you as soon as possible. And come and attend our monthly developer update every second Thursday of the month. Okay. All right. Thank you, and see you on the internet. All right. Bye.